NH2Cl, draw the best Lewis structure, show all electrons and bonds with the lowest formal charge, show all non-zero formal charges, then answer the following questions. What is the hybridization, electron geometry, approximate bond angles, sigma, pi, and is the molecule polar or non-polar? And you don't have to answer for ions. But this is not an ion. Now, I should just get an extra piece of paper because there's so many questions. The question takes up the whole page. There we go. So for NH2Cl, your best Lewis structure will look something like this. And the position of the chlorine doesn't matter. It could be in any of these positions, so it could be left, bottom, or right. And from here, we'll start answering the questions. What is the hybridization? Well, we have 1, 2, 3, 4 electron groups, so that's going to be sp3. Electron geometry is tetrahedral because sp3 tetrahedral and bond angle of 109.5, or in this case, less than 109.5. This one is question 6. So 0906. Less than 109.5. And in this particular molecule, so remember the first bond between any two atoms is a sigma bond. So sigma, sigma, sigma. There are 3 sigma bonds. There are 0 pi bonds because there's no double or triple bonds. The only time you'll ever have a pi bond is if there's at least one double and or triple bond. And is the molecule polar or non-polar? Well, I would say 2 things about that. One is, anytime you look at the central atom and there are different species around the central atom, and so a hydrogen would be one, a chlorine would be another, and a pair of electrons would be a third different thing or species, that's gonna mean that it's polar. Only when everything around the central atom is exactly the same will it be nonpolar. So it's going to be polar. And when I think polar, another way of doing it is to actually draw the shape. And it's tetrahedral, so put an N somewhere. Let's see. I'm going to put the pair of electrons up top. And then I'm going to put in each of the 3 places let's put HHCl. And now I'm going to do what I call draw dipoles. And I actually can't believe that I did not ask you to draw dipoles for this, but that is part of how you do this answer. So dipoles are so they're using what are called plus arrows, where the plus part of the arrow is towards the less electronegative atom. And the arrow points towards the more electronegative atom. And between hydrogen and nitrogen, nitrogen is more electronegative. Between hydrogen and nitrogen, same thing again. And on the, the second exam and future exams, if we look at this little list here, let's see. So this is our conversion and equation sheet. It shows some elements and some of their electronegativities. It turns out nitrogen and chlorine have the same electronegativity, although if you go out to the second decimal place, you will see on the internet that there is a difference, but for this course, the same, considered the same. So no dipole to draw here. If you look at these two dipoles, there's nothing to cancel the dipoles out. And so our conclusion is that this molecule has polar bonds. Those polar bonds, those dipoles associated with the polar bonds do not cancel out. This is a polar molecule. So I'm just going to write here, polar molecule with polar bonds. So now we've answered all 6 of the questions that we were asked about this. And yeah, I don't know if I can get the questions and the answer on the same page, in the same view, but there they are. Any questions about that?